Hello, and welcome back. Today we are going to talk about another very practical modifier, one that's especially useful when you're dealing with assemblies that use bolts, screws, or press-fit pins. It's called the projected tolerance zone. Now, this modifier is extremely important in situations where parts are stacked together. For example, two or more plates that are bolted or fastened. Here's why. When you have a threaded or press-fit hole, say in the bottom plate, any small variation in orientation during manufacturing can cause that hole to be slightly tilted. It might not look like much, but when you insert a long fastener or bolt through that hole, that tiny tilt gets projected upward, meaning the bolt itself will lean slightly. And if that bolt leans, it can cause interference with the mating part above it. Maybe it rubs against the wall of another hole, or the bolt head doesn't seat properly. In worst cases, it can actually prevent assembly altogether. So how do we prevent that? That's where the projected tolerance zone comes in. By applying a projected tolerance zone, we're not just controlling the orientation of the hole at the surface, we're also controlling how that orientation behaves through the thickness of the mating part. In other words, we're extending the tolerance zone upward into the space where the fastener or pin will actually exist when the parts are assembled. Let's look at an example. Suppose we have two parts to be joined using a bolt. On the drawing of the lower part, we have a position tolerance of 0.25 millimeters. Beside the tolerance value, we have a P sign and a number which is in this case 14 millimeters. This means that the axis of the threaded hole must stay within a cylindrical zone that's 0.25 millimeters in diameter, and that cylinder is projected 14 millimeters above the surface of this part. Why 14 millimeters? Because that's roughly the thickness of the mating part, the one sitting on top. So we're making sure the fastener's orientation is controlled not just inside the part, but through the whole height of the assembly stack. This helps ensure that when the bolt or pin is inserted, it stays perfectly aligned with the hole above it, preventing misalignment, cross-threading, or unwanted contact between parts. In drawings, the projected tolerance zone is usually indicated by the projected tolerance symbol P in the feature control frame, followed by the projection height. Sometimes you'll also see a chain line drawn above the feature on the drawing, with the projection height noted, for example, 35 millimeters, showing exactly how far that zone extends. So, to summarize, the projected tolerance zone is used when fasteners or pins pass through multiple parts, and orientation variation could cause interference. It ensures that the axis of the hole or fastener remains within a controlled orientation through the full assembly height. The projection height should be at least equal to the thickness of the mating part or stack. In short, this modifier helps designers prevent costly assembly problems before they ever happen, ensuring that when you tighten that bolt, everything lines up just right. That's it for this lecture. In the next lecture, we are going to talk about the free state modifier. See you in the next lecture.